Worksheet 16C. Combine loading. Determine the total state of stress at point H, top of the rod XY plane, and the K, the side of the rod XZ plane, caused by the load shown the total stress at each point on stress plot below. Dotted line represent the neutral axis. So this is plot we want to solve at the end. And from here, as you already familiar with the internal forces in worksheet 16A and 16B, of course you familiar with all of this, but I want to continue to complete the solution. But internal forces, let me cut this rod and consider CHK. Draw the free body diagram, and at the cross section through H and K, there are 6 unknowns: mx, my, mz, fx, fy, fz. You use equilibrium equation, you can find out, and the answer it have to be on that members, on that section, which is CHK, on up here. And then I can go ahead to, similar to worksheet 16B, I can draw the, so that is posed, so that we get easy to see that cross section through HK by consider the segment DHK. So D by D, I mean I choose the fixed point here, D, at the fixed support, so that is DHK, and I just change the direction of fx, fy, fz, mx, my, and z on member CHK to DHK, so that what I have in here for forces and moments. So we have fx, we have fy, we have fz, we have we don't have mx, so no torsion. We only have bending moment in y direction about y axis, and bending moment about z axis. And from that we can similar to the previous problem, we determine the stress for each load and then combine together. So let the next step, as you can see, stresses that we want to determine for H and K, right? For point H and K, and from that we have to consider each of them. So first we have 24 kips, so let's work out that is stress caused by Fx equal to 24 kips. 24 kips. From here, as you can see, it in the first 24 kips go into the cut, so it will be create a compression normal stress in compression for both S and K's, because that is actual load. So any point on that cross section should have the same. So you have A, H and K, both H and K, we have the same, and that is on the X perpendicular to X plane, so that is along the x-axis. So sigma x equal to P over A for the actual load, and that is compression. So 24 divided by area, so 6 by 6 inches, and you can see this is a square 6 by 6. So from that we can find out this number is 0.6 negative 0.667 units KSI, or equal to 0.667 KSI in compression. And the next one, it will be stress caused by Fy, and Fy is equal to 2 kips, and it's shown in the DHK here. It's in the negative y-axis, so it will in y, so it will be tau xy, as you can see there. And for the tau xy, if you have that two capes, if we can draw the cross section of through x it's square, so let's put the square here. So this is h and this is k, and we have the this is y, we have x, y, and this is h, and this is z, you see there. And then the two capes go opposite of y, positive y, so here that two capes, and that two capes, as you can see, that either share the in-plane shear force, so that create the shear stress, and the become the neutral axis is perpendicular to the force, shear force, and that create the maximum transverse shear stress at h and 0 at k, you see there. So from that we can have for h, we have the maximum, and in this case tau on the x plane and in the y axis and in the negative. So as you can see, tau xy equal to negative 2 times q. For q, let's write down the equation first, so that v q over it, and let me put down here for the cross section. So the q, let's put here. So this is one we are talking about, and from that q neutral axis we can find out equal to the y bar times a apostrophe. So let's write down here, it equal to v to negative 2 q equal to y bar in this case is from the neutral axis to the centroid of the outward area, so that equal to the whole thing here is 6 inches. This is 6 inches. So that one, as you can see, it equal to 1.5. 1.5. And then you have outward area, it will be 6 times 3 over itbh cubed, so it's that 6 times 6 cubed over 12, and then time t is the thickness or the width is also 6. So from this number we will get that equal to negative 0.0833, and the answer is KSI. And then we have K is at the outermost fiber, Q equals 0, so tau xy for K equal to 0. Now we go to find out stress for 3 capes. Stress caused by Fz equal to 3 capes, and that will be shown in the next video. We stop here and we continue for the next one to complete this solution.